Okay, it's the top of the hour. Welcome, everyone. This is a session of the DETNET working group at IETF111. Lou Berger and myself, János Farkas, co-chair the working group. And many thanks for Ethan for taking care of the secretary job, like minutes. This is the IETF Note 12. I suppose everybody is familiar with it in details. If not, then please check further. I would like to highlight that by participating, you acknowledge that everything is said here becomes part of our permanent records. And also, I would like to remind you the conduct guidelines, like the professional behavior, how to act in these meetings. If you are not familiar with the details, please check again offline. As for meeting logistics, please keep in mind that the blue sheets are now completely electronic. Remote, as indicated here, you get the full Mitaco, and on-site, please join in the on-site tool. There is the QR code on the screen, further for me, and also for the queuing up on-site in the floor mic, please use the on-site tool. And also for the remote participants, when you are not speaking, please mute yourself. I guess we are familiar with this mixed mode setup with the queuing I just mentioned, the blue sheet mentioned. Also very important for the note taking, please join the note taking. You can find the link at the usual places. It's a joint note taking. Please check, for example, what you said was captured accurately. We have this session, and we also have a joint session with the PALS and the MPLS working groups on Wednesday. You find the logistics as usual. And we ended up with a quite packed agenda, so this is why I'm trying to be quick. Again, I'm not reading out the agenda. You find it at the usual place. As for the status of the working group documents, we have the bounded latency draft actually at 0:45, sorry, 48. So it's getting really towards the publication. And also the Yang is very close to the publication. And we have recently requested publication for the OEM framework, which passed working group last call like 2 months ago, and going forward in the pipe. We have the MPLS OEM document, which just recently passed working group last call, and discussion is still ongoing on the list. The draft is with the authors to address the comments after the discussion is concluded, and we are going to move forward with the draft afterwards. We thought to mention that there is a new thing that when we go to working group last call with our drafts, we ask for early routing area directorate review. So we did that for the MPLS OEM. That's the first one we are doing it. One of the drafts have been recently adopted. This is the packet ordering function, as you see here. And we also have a candidate for adoption, the large-scale requirements. It's actually the IPR call is ongoing, so there will be a presentation about the draft itself later on. Okay, and we also received a liaison statement from TGPP SA2 that's going to be presented next after the chair's intro. And I would like to remind people about IPR disclosures. Like we follow the usual process. We do the IPR calls before adoption and working group last call. And also if there is a new author joining a draft, we request to declare IPR from the new author. As for progressing our work, please use the mailing list. I'm happy to see the discussions happening there. And We can schedule additional virtual meetings, an interim or working group meetings. I guess we come back to that for one of the topics later on, but we are absolutely open to that, and we have the facilities to foster progress of the working group. I guess that's it in short and fast. Do you want to add anything? Okay, so let's move to the next on the agenda, which is the liaison statement. So Laurent, please go ahead.
Okay, thank you, Mr. Chairman. So, hello, everybody. I hope you can hear me well. So, I'm Laurent Thibault from Nokia, and I'm a delegate to 3GPP-C2, which is the group defining the 3GP architecture. And as part of, can you please show the slide number 2, please? Yes, thank you. And as part of 5G work in release 16 from 3GPP, we define how a 5G network can be put as an element of an IEEE time-sensitive communication network. In release 17, we enlarge what we did in release 16 to generic IP networks. And in release 18, there is currently a study item, which means that we study before doing specifications, where we see how we can insert a 3GPP-based network within the DETNET infrastructure, within the DETNET infrastructure as defined by IETF. And as you can see on this picture, we consider a DETNET controller, and the DETNET controller has an interface to the northbound part of the 3GPP base DETNET node that acts as a transit node. And this transit node has two kinds of interfaces. On the left, you can see UE part interface, and on the right, you can see the N6 interface, which is the interface to the fixed network, and which terminates as an user plane function. Coming back to the UE part of the picture of the 3GPP DETNET node, I want also to clarify that the figure that I'm presenting is an abstracted view of the 3GPP figure, which is 3GPP technical report. And it's abstracted, but if you wish to look at the figure in the 3GPP report, it will be in slide 3. No need to see it here, but you have it for your reference. Yes, there. And coming back to slide 2, thank you. The UE can either be integrated by some magic in a DETNET node acting as a host with a magic interface, which may not be an Ethernet-based interface, which can be a proprietary interface, or the UE can connect to a one or multiple DETNET node acting as hosts. And this latter case depicted below can correspond to two cases. A case where the IP address of the hosts are somehow statically configured, i.e. in the 3GPP network as part of the subscription of this user equipment, the set of IP addresses that may correspond to these DETNET nodes is configured. That's one case. And the second case is the case where the IPv6 prefixes allocated to the DETNET node hosts that are shown on the bottom left of the figure can be allocated dynamically, i.e. we use the IETF-based prefix delegation, and there is some entity in the 5G network that acts as the delegating router that provides a dynamic IPv6 prefix, out of which the UE can allocate individual /64 prefixes to DETNET nodes, to hosts. Okay. This being said, I'm coming now to the liaison itself. And on the liaison itself, we ask a few questions to IETF because from our 3GPP perspective, we want to work as closely as possible with you and to be as much as possible compliant with IETF. And we would not like too much, or we don't like at all, having to define a 3GPP between bracket proprietary solutions if the problem can be solved by you, by us here at IETF. And I have letters A and B, and this letter A and B refers to the liaison that 3GPP has sent to IETF, and you have a pointer to this liaison on the slides. And in the first part of the liaison, we ask a question about the requirement that the DETNET controller can set done to the 5G based DETNET node. We observed that up to now, IETF in its models has defined end-to-end QoS requirements, for example, in terms of delay or packet loss. And we observed that the 3GPP based network would be only one transit node within a more global network, where we would have other intermediate nodes, for example, that are not 3GPP based, that are between bracket routers, fixed routers. And for that, we ask ourselves the question whether IETF in its model will define node requirements that the DETNET controller can send to individual nodes, where the DETNET controller would transform the end-to-end requirements, for example, in terms of delay between the host on the right part of the figure and the host on the left part of the figure. So where the DETNET controller would break this end-to-end delay requirement into per node requirements that would apply, for example, to the DETNET intermediate node shown on the picture and to the 3GPP base transit node also shown on the picture. Maybe I can stop here for a while before I will expose, let's say, the other part of our questions, which are tagged with the letter B, and which are more about what 3GPP can expose to the DETNET controller.
I think you can go ahead, Laurent. I don't see anybody in the queue. So please go to the...
Okay, so thank you, Mr. Chairman. So the other questions we have are about what 3GPP can expose. And we have defined a set of parameters that 3GPP can expose. So first, we consider that, of course, 3GPP could expose information per RFC 8343, 8344, possibly 8349. And in our liaison, we ask IETF about feedback about what we think about the usage of these RFCs. But on top of that, we mentioned that we could expose other information. We have already mentioned that we can expose, for example, the MTU size or other information. We have been debated, and to be honest with you, the debate we didn't conclude one way or another. Whether it would make sense that 3GPP would be able to expose N6 IP forwarding information, i.e. information that the UPF can learn via, for example, routing protocols with other DETNET intermediate nodes. So whether IETF would see that as useful or not. And also other possibilities, whether 3GPP could expose what we call node capabilities, for example, the lowest supportable delays that 3GPP could support between a UE and an UPF. And to finish my presentation, for 3GPP to be able to expose information about, let's say, its environment, it may or might, up to you to comment, mean to, let's say, have some discovery protocols between the 3GPP base DETNET transit node and other DETNET intermediate nodes. And that's why I put B discovery above the N6 interface of the 3GPP network. So the question is whether 3GPP would recommend to have some specific discovery protocol here, or whether IETF considers that 3GPP can pick and choose among the existing protocols. And the background of this question is that when we discussed in the past as part of release 16, integration of 3GPP network into IEEE TSC network. That's 3GPP. We leverage sort of the LLDP protocol defined by IEEE, and so to see whether you would welcome us to leverage an equivalent protocol done by IETF. And that ends my presentation. Thank you.
Thank you, Laurent. Thank you, Laurent, and thank you for coming and presenting. We have a question from Chasson. Chasson, please go ahead.
This is Xiusong from Huawei. Just as the author of the DETNET Young model document, I try to give some response to some of the questions. I think.
Can I suggest actually that we provide a written response?
Yes.
Because we actually need to give. They're asking that it's covered now with your name, but what they're asking for is we write up a liaison response, and so we're going to need what you're saying.
Yeah, sure. I just try to give some technical response from the young model perspective. Actually, from the exposure of the node information, maybe I recommend to refer to the existing maybe TE topology young model in IETF that has already been defined in other working group. And for the end-to-end node, maybe latency distribution, I think that is part of consideration from our DETNET young model, but it is not included yet. So if working group chairs also think it is necessary, especially for 3GPP work cooperation, we think it may be request further work for DETNET young model. But the existing document is quite stable, so maybe we can try some new work about it. Thank you.
Okay, thank you. So I would like to take the action point of starting with the draft. Of course, we will develop in the working group on the list. And if anybody is interested in the early drafting, then please drop me an email. And thank you for the discussion again. And maybe one point to make that, as Ron pointed out, that some of the things we have on the slides is not part of the liaison or the technical report, like the lowest support of a delay and so on.
Yeah.
Okay.
Yeah.
Thank you very much.
Sort of. Okay. Excuse me. I should raise my hand.
Move on to the next item on the agenda. Many thanks.
Greg, are you online in the room?
Greg, yeah.
By the way, for everyone presenting, there is a timer. That timer you should see on your screen, on the bottom of your screen, and that includes the Q&A time. So please leave some time for the discussion. Thank you.
Okay. Let's review the work that we have done since last discussion on OEM for deterministic networks. So firstly, for MPLS data plane. This document been in a working group last call. We received very good comments, and we thank you for Ethan and Tinran for their thorough reviews, constructive comments, and thoughtful suggestions. And really, especially for Ethan, his help enormous. It's unbelievable the work that he done in improving the document, the quality. So there, DETNET OEM in MPLS, as DETNET OEM in general, addresses two sub-layers, forwarding and DETNET service. So, and it uses for MPLS pseudowire associated channel header, and it's been defined. But what we found that for DETNET service sublayer, which can be more comparable to operation of MPLS OEM over MPLS multi-segment pseudowire, this associated channel header requires some extensions. So that is being reflected in the document, and we improved some definitions and descriptions, added some clarifications of the fields that been extended for the DETNET associated channel header. So next slide, please. And so this is a rendering of DETNET associated channel. So the first 4 octets are well familiar for MPLS pseudowire. We propose the reserved field to be used for DETNET MPLS OEM sequence numbering, so that like on MPLS DETNET sub-layer service pre-O functionality can use this information. Yes, the format is a little different, but because of different first nibble in DETNET control word, it's all zeros, and in the DETNET ACH, similar to pseudowire ACH, the first nibble is the value is 1, so that can be recognized, and then a different format of a sequence number can be used for the pre-O functionality, mapping it to the monitored DETNET flow. And an extension is being added another 4 octets that includes fields as node ID, level, flags, and session identifier. And as was suggested, we added some clarification to definition of level field and session ID. Next slide, please. So as we understand, imagine that the working group last call is still open, and we send our responses to the commenters and waiting for their reaction. So we're running the working version that includes updates that based on received comments, and once we can converge, then we'll upload the new version. Next slide, please.
And I don't see Tiran online or on MeetEcho, but we're waiting for, I think that's the outstanding.
Yes, he was patient with us coming with the answer, so I'll remind him and ask him to review their responses, and then, yeah,
If we're lucky, he's here this week, and maybe you can talk. If we're not,
in the previous session, he was doing remote presentation, so
Okay.
I think that he is remote, and I imagine the timing is unfortunate for their
sure, understand.
Asian.
Yeah, it's tough.
Yeah, it's suffering. Okay, so the work on, there is some clarification, and we discussed one of the additional methods of doing DETNET OEM over IP as using IP and UDP encapsulation, so that active OEM is encapsulated in UDP tunnel, and that tunnel is mapped to DETNET flow that is being monitored. So in that way, regardless of whether it's a UDP-based OEM protocol or ICMP, so all OEM that is used to monitor the particular flow is one UDP flow, and that simplifies the mapping to the DETNET flow. But as a drawback of that, to OEM packets, this DETNET domain will look as a single hop. So thus, we cannot get any visibility in the transit DETNET nodes. So that's what tried to convey in this figure. I don't know how successful it was. Any questions?
No, I'm just hearing some crosstalk. I didn't know where it was coming from.
From the next room.
Okay.
So there, I don't know if we're interfering with them, but we definitely can hear them. Next slide, please. So there was not much because we in the group actively participated in discussion of OEM framework document and then MPLS DETNET OEM. So this document probably did not receive yet reviews and comments, and we welcome you to look at this document as well, so which will make it easier for us when we get to the working group last call. And we have almost 3 minutes.
Well, I did have a question. This is, I don't pick any hat. We've had discussions previously about how to do the association in the IP flows with the OEM and the pack and the DETNET flow. UDP is one way. In the draft, you talk about others, and you highlight the use of a DETNET DSCP. And I think as the base protocols say, use of DSCP is allowed, but there is no single DETNET DSCP, and there's many ways to do association.
Yes.
And it would be good to make sure that the document is well aligned with the data plane documents and allow any of the types of association.
Right, but okay, might be need to reward. So their idea was that to do fate sharing and network treatment of OEM packets as close, well, the same as a monitored flow, the same value of DSCP marking that applied to DETNET flow must be applied to the DETNET packets. So,
what if the IP network isn't using DSCP for flow identification?
That's interesting.
That's allowed in the document.
Well, basically then the same would be applicable to OEM. If network is not considering DSCP marking, then it doesn't matter what the DSCP marking OEM would be.
Right. So I just think that you want to be clear about that case. As it reads right now, it implies that DSCP is the only methodology, and it's
okay.
not.
Okay. Okay, I see. So it needs some additional text just to clarify that whatever policy, QoS policy is applied to DETNET flow being monitored, the same policy must be applied to DETNET OEM.
Precisely.
Yeah, and then probably covers all the cases.
And I don't see Pascal in the room. He had some comments at the last meeting. Have you been able to sync up with him to make sure his comments are addressed?
I'm sorry. I'll follow up on that.
Yeah, take a look at the minutes. There's some good notes in there, and then follow up with him on the list. That'd be great. Thank you.
Okay. So, any more questions? Okay, we saved 20 seconds.
Thank you. Shusong?
Hi, this is Xu Song, and I will introduce some update proposal for our work about DETNET controller plan framework. Next slide, please. Just to give an overview about what we have done in the existing document, we have DETNET controller plan requirements, which align with the existing DETNET data plan framework context. And also we have DETNET control plan architecture, including centralized model, distributed model, and hybrid model, which aligns with the definition in IEEE. And also we have DETNET control plan for DETNET mechanisms defined in DETNET architecture, which I will go to details in the next slide. And also, as Greg have already introduced, that we have some very solid work about DETNET OEM, which related, highly related to DETNET management work. So we just give some DETNET management work overview and provide reference to the existing work in the working group. And based on the existing work, we have some updated proposals to the next version of the document. The first one is just based on the our understanding of the update of DETNET working group recharter and or milestone update. we want to propose some detailed descriptions about DETNET mechanisms for its requirement to DETNET control plan. In the existing version, we can see the box in the left hand. The DETNET mechanisms is listed as explicit path, resource reservation, PREVF support, and the data plan specific considerations, which include IP, MPLS, and SR networks. Considering the red part of the mechanisms could be described in detail if considering to provide bounded latency, especially in the enhanced DETNET scenario. So we try to make it more detailed in next version if working group think it is reasonable. Basically, we want to separate it into 4 parts. The first one, as the picture shows, I think it makes people understand it easier. The first part is DETNET resource collection. For example, if the DETNET bounded latency is provided by some time slots, and it can be some time resource that could be collected by the DETNET controller if there is any. And the second part is DETNET path computation, because the DETNET service is supposed to provide service with bounded latency or high reliability. So we should calculate the path based on these constraints, and also with some limitation of the resource to guarantee this performance. And also in the third part, we think the path allocation will be requested, but not necessary, because if there is no controller and in a distributed mode, the path allocation will not exist, and because the path computation will just happen inside the DETNET domain, inside the network. And also the fourth path is the path establishment and resource reservation along the whole path, which provides the path for DETNET flow, which is defined in DETNET data plan. So this is the first proposal. I noticed there is someone in the queue.
Yeah, Carlos Bernardo, Juicy, one question. Maybe I missed that, but all this consideration for the control plane and the DETNET, are we assuming that in the future we will be adding somehow the raw specific part to this, or this will be a standalone document, or how we plan to do this? Because I guess there are things that probably are raw specific that will need to be potentially considered there. Is there any plan for that?
No, go ahead.
I think this is just a framework. It's kind of requirement for further extensions for a particular protocol if it is requested. So it will not inside this document, if I understand.
Yeah, I understand that. Right. But even from a framework point of view, I guess there may be things that are probably wireless specific that may be added there.
Yeah, I would say that we would expect for it to be reasonable to have a raw specific document. But if there's just a small amount of text related to raw, why run a whole nother document? And let's do it in this one. So I'd say come up with the raw, identify the parts that are raw specific, and then from there we can look at it with the raw working group chairs as whether or not it makes sense to run a separate document or an integrated document.
Okay, thanks.
Sure, thank you.
Thank you for your question. And the second proposal is about the relationship between control plan and management plan. As I have mentioned, that the DETNET control plan is for setting up DETNET paths with resource and the parallel branches for bounded latency and the reliability, which provides the valid path for DETNET control for DETNET data plan, and the data flows just transit through the path that has already been set up by the DETNET control plan. And for DETNET management plan, it will provide the result of performance monitoring, connectivity detection, which is very core part of the DETNET idea, because we try to provide more high-level SLA guarantee. And so there we try to maybe add some possible text about the interaction between control plan and management plan, which means that when the management plan shows that show some feedback from the management plan. We need more, for example, resource to satisfy the deterministic requirement. Their request some update in control plan. That means that the three parts for DETNET could be combined together, and it can interact with each other to provide the DETNET service. Yeah, this is the last page. We just want to a working group to know we are trying to update the document and to know whether people think this is reasonable. And we think if it is stable enough, we can request a working group last call. Thank you.
Okay, thank you. One last thing to remember is we talked about the last meeting, integrating some text from Carlos related to
yes.
multi-domain. So we'd like to see that happen before going to last call also.
Yes, very happy to see that.
Thank you.
Thank you.
Okay. Okay, this is a summary about the MPLS over IP proof document. The next slide is showing practically the table of content in the document. This is a document to describe how the DETNET IP data plane can support the replication, elimination, and ordering function based on using MPLS over UDP technology. So the content of the draft is pretty stable. We have requirements. We have description how to add the pre-of functionality to the IP DETNET data plane. We are covering also the parameters which are needed for control and management plane activities, and security considerations are also covered. The next slide is showing the history of this document. So there were many discussions on the mailing list during 2021. And as a result of those discussions before we have adopted as a workgroup document this draft, we have achieved, I think, a pretty good technical content and stable content on the draft. There were clarification in order to highlight in the text that we are using underlay UDP IP tonnage between an overlay of DETNET relay nodes. We had also clarification on the parameters and the use cases, how to use that. So this is what was updated in the document. So the text is pretty stable. And this draft leverages the existing DETNET data plane building blocks. There are no new IP headers defined. This is a generic IP solution. It works both for IPv4 and IPv6. It defines the pre-of capabilities at the DETNET service sublayer where it belongs to, and the solution allow to use any IP routing techniques in the DETNET IP domain. And there is also no requirement to do additional processing on the transit nodes. So we think that the content is pretty stable. So we may ask the group and the chairs to consider a workgroup last call on this document.
So we just started a poll, so to be able to gauge out of the room and in the room, basically saying, does anyone have any objections? If you're in the room, please feel free to join the queue and make your comment. If you're not in the room, please feel free to do the same. Answer and then join the queue if you have any objections. We'd like to hear from it now. So raise hands means you object, just to be clear.
Yeah.
We have one person who's raised their hand. We have about a minute or more to hear from that person if they'd like to bring their objection now rather than wait to the last call and put it on the list. Oops, don't mean to end it, but maybe I did. Okay, well, thank you. I think we should expect last call, and we'll hopefully hear from the one person who objected.
Yeah, sure.
Thank you. I don't know how to get rid of this.
Start a new pool.
Oh, okay.
That's great. Okay. So these slides are about the packet ordering function. Next slide, please. The draft is focusing on how to reorder the packets, because if you have replication and elimination functionality in the DETNet network, that may result in out of order packets, and that might not be acceptable for some time sensitive application. So this document is describing packet ordering function algorithms in order to restore the correct packet order when these replication and elimination functions are used. So we have defined in the document the requirements, and there are two POF algorithms described in detail. One is a basic algorithm, and the other is a more advanced one for more challenging network scenarios. The draft is also covering what parameters are needed for these algorithms in order to be used in real network. So control and management plane parameters are listed and highlighted in the document. And also security considerations are there. The next slide is showing the history of the document. So for this draft, when it was an individual draft, we had a lot of discussion before adopted by the work group. I have listed here all the people who have contributed to that work. That was a very good discussions, and we have really updated the document for the parameters, for the use cases where it can be used, these algorithms, for the description of the algorithm itself, what is the relationship to the replication and elimination functions. And there was also discussion about the possible delay variation caused by the POF functionality. So regarding the document, it is describing the POF function like any other DETNet functions we have defined as a building block. So if you would like to set up end-to-end network in order to fulfill the characteristics requirement of the flows over that network, you have to use many of these building blocks. And one of those building blocks is the POF functionality. The next slide is showing that the technical content is stable since IETF 113. So here again, we intend to ask the work group and the chairs to consider a work group last call as the document is in a pretty stable state. Thank you.
Okay, so I'd like to try something slightly different. Same question of objections, but this time only raise your hand if you object, and do not raise your hand if you have read the document. If you have not read the document or do not have any objections, please don't vote. It's not voting, whatever, respond. Excuse me. So again, raise hand if you object. Do not raise hand if you've read the document. And we have someone in queue.
Esa Mohammadpur from EPFL. I would like to add some comments here that might be useful for the draft. We have done some studies on the reordering and adding resequencing buffers. And I would say that the functionality of the POF is actually what can be done by resequencing buffers. So, and like some parameters, I feel like that could be nice to have in the draft about the buffer size or the timeout value or the PO max delay, I think it is referred in the draft. We have done the dimensioning in a separate work that I think that it would be nice if somehow could be referred so that the people who are interested to use the parameters to have some idea on that.
Yeah,
just a comment.
Yeah, I think that would be definitely worth to discuss. In the document, we have listed only the parameters which are mandatory. For example, buffer size, it can be implementation specific, but buffer size you need. You can also calculate the buffer size from the characteristic of the flow and the parameters, because based on that, you will know exactly how much buffer you need per flow. But definitely this is something, but if you are implementing it, of course, this is an important implementation parameter and the design parameter.
Okay, thank you.
Thank you.
Thomas Eckert. So sorry, hadn't had the time to read the later version, but was wondering what amount of validation work has been done in terms of, for example, trying to implement this in P4 to see how well it would work, or kind of, you know, what's the, other than the always working software implementation, what validation is there?
Yeah, I know about some validation implementations. We have also tested in our lab. So there are already implementations and they are working according to these standards as we have described in the draft.
So I think in other working groups and so on.
Peng, if you can join. We're just getting the next speaker lined up because he's remote.
Yeah, so I was thinking that, you know, any of such implementation experience would be great to write someplace. I think in other working groups they use a wiki or something, or on the mailing list, so it would be lovely to hear.
Okay.
Okay, thank you very much. We're going to get moving to the next speaker.
Hello, everyone. This is Peng Liu from China Mobile. And it's about the requirements of large-scale deterministic network. Next slide, please. This draft aims at the large-scale deterministic network with long hopes, larger per hop time variation, great number of flows and or multiple domains without the same time source. This document describes the technical requirement, including the data plan enhancement requirement when the different deterministic levels of applications coexist and are transported. We have updated the draft from version 0.1 to 0.5, comparing to the last presentation in IETF115. And we received many of the comments and refine it. Yeah. So the main updates are that we summarize the key attributes of large-scale DETnet based on those comments, and we restructured the document for better alignment. First one is remove section 3 of the old version and merge it into requirements section. And we refine the technical requirements section and add data plan enhancement requirements section. And we address the comments from Lou, Wallace, Fan Yang, Lei Zhou, and Tianran. And thank you all. And this morning we got new comments, and the co-authors has been working on this. And there are also some editorial improvement. Next slide, please. So the key attributes of the large-scale DETnet, here we define a large-scale DETnet network as networks that require DETnet solutions for typical one or more of the following key attributes. First one, there is a relaxed clock synchronization or no clock synchronization in different domains. And second one is end-to-end path is a combination of short and long distance hops. And third one is there are various transmission rates supported at the different ports and on different network nodes. And there are a large number of flows which may have different level demands of DETnet service across multi-domains. The topology change and failures of link might be more common. And the mechanisms used to ensure bounded latency, such as a queuing mechanism, may be multiple to have different configuration or parameters in multi-domains. And such domains are normally within a single administrative control network or multiple cooperating network within a closed group of administrative control. It is overall technical requirements. We make it more closely aligned with the key attributes, and there are some changed compared to the last version. First one is tolerate the time asynchrony, and the second one supports a large single hop propagation latency, and the second one is accommodate the higher link speed. For the requirement 4, we changed it to be scalable to the massive traffic flows. And requirement 5 tolerates failures of links or nodes and topology changes. And for the last two requirements in the last version, we merged into one requirement support enhancement of queuing mechanisms. It includes the multiple queuing mechanisms and the switch over crossing multi-domains, and its overall technical requirements now. Next slide. In maybe version 02, we add the data plan enhancement requirement. In this version, we have 4 requirements. The first one is support aggregated flow identification. Because the number of individual flow is large, and they may randomly join and leave the aggregated flow at each hop. So the explicit flow identification make it easier to quickly distinguish the different kinds of DETnet flows instead of relying on the prefix on wait cards as indicated in the RFC. And we also received comments this morning about the flows identification, and we think we will deal with it. And thanks for the comments. And the requirement 2 is support meta information used by functions ensuring deterministic latency. It should support the synchronized or asynchronized queuing mechanism requires different information to be defined as DETnet specific metadata. And the data plan processing efficiency also need to be considered, because if we encapsulation too much of the data, it will lower down the processing efficiency. And requirement 3 is about support redundancy related files. Sequence number now is only metadata currently defined for redundancy feature of DETnet. And MPS data plan use DETnet over MPS label stack to carry it. And the native IPv6 data plan should be able to carry this information too. And so the last requirement of the data plan enhancement is support explicit path selection. It's also about that IP data plan enhancement is required to support the explicit path selection based on IP source routing or SRv6. Yeah, thanks. So this draft is in the process of the adoption call, and we wish more people could review this draft and reply to the mailing list, especially for the authors who submit the data plan enhancement solutions draft. We welcome them to join this work. And okay, that's any comment?
Can you just repeat the last sentence? I just missed what you said. Just say the same sentence again. Yeah. Did you say who are you asking to join?
The people who submit the solution draft.
Okay. So the from the last meeting, I can't remember if we talked about it in the last meeting or not, but there's the next draft, if that's the one you're referring to. There's some very similar information. And one of the comments you're going to get during the adoption call is, once this document is a working group document, yeah, we'd like to see some of the text from the next presentation come into this work.
Yes, I think the authors of next presentation is also the co-authors in this draft, and we have been working on merge some of them.
Great.
Yes.
We really look forward to seeing that merge. And one of the other things is we've talked about on the list that some of the information and some of the what you've covered here is really just generic implementation issues for DETnet and not so much large scale. We think they're good issues to capture. And so it'll be important to distinguish in the document which are just implementation considerations and which ones are really due to scale. And
yes, we think that there are 2 points. One is that maybe some new problems caused by large scale, and there are also maybe some issues should be enhanced, but maybe also in the current DETnet.
Yeah, perfect.
Yeah. Thanks.
Thank you very much. Now we have the next speaker, Kwan. I think they might be remote. I'd also like to remind people of what you see on the left-hand side. There's two things there that are important. If you're in the room and haven't signed in, do so. We'd like to have you on the blue sheet. We're getting some echo. And then the other thing is we'd like to remind you of the requirement to wear a mask in here, and that means to fully and properly wear a mask, except if you're at the front of the room speaking, or very briefly, they say you can take it off to drink, but it should be very brief. And we just want to remind you of those two things. Thank you. Kwan, please go
on. This is about DETNet enhancement for large-scale deterministic networks. Okay, last slide, please. Thank you. We have presented this draft at IETF 114, and thanks for the suggestions from Xuesong and Lu. We should start the requirements and align with RFC 8938. So this version, we update and discuss the gap analysis when applying the DETNet data plane as per RFC 8938. First, describe the primary goals and then the characteristics, and then we give the gap analysis of the large-scale deterministic networks. So based on the gap analysis, we propose the enhancements of that satellite data plane, including the enhanced functions, metadata, treatment, and encapsulation. We also provide the further controller plane considerations. Last slide, please. So first, let's start with the gap analysis. The primary goals for the DETNet queues is to support the different levels of the DETNet queues for multiple services in large-scale networks. And the last is for the network operators is to support the utilization of the network resources. And then the characteristics of large-scale deterministic networks is divided into two parts. One is the large-scale dynamic flows, and another one is the large-scale topology, including the large number of nodes and links, high-speed, long-distance transmission, and it may be crossing multiple domains, and the nodes may be interacted with different subnetwork topologies. And then, based on the goals and the characteristics, we try to summarize the gap list, including the functions to provide aggregated flows identification in service W and the deterministic latency in forwarding W. For example, for the aggregated flows, it requires large amount control signaling to establish and maintain the network data plane per flows or aggregated flows. And for deterministic latency, it may be challenging to compute paths due to the multiple metrics and the frequent topology changes. So it may be lead to support the enhancement of resources allocations and the queuing mechanisms. Above of that, it also lead to provide DETNet specific metadata for enhanced functions, and the treatment may be enhanced at the key loads, for example, the ingress loads and the transit loads. And finally, the encapsulations may be added for IPv6 and SRv6. So last slide, please. So the enhanced queues related functions and that specific metadata should be supported for enhancement of flow identification and packet treatment aligned with the gap analysis, including functions in surface sublayer and forwarding sublayer. Maybe include the function related to the metadata and the encapsulation and so on. So we provide the enhanced function, maybe include the flow identification for surface level aggregation or the deterministic rules such as the loose and the distributed route or the inter-domain routes. Or maybe it may be also include the resource and the treatment and the queuing treatment. And then the metadata may be included the deterministic latency information or other information may be conferred by the working group. So last slide, please. So finally, we also try to provide the further controller plane consideration. It may be covered with the 学送 the framework of the controller plane. Then other maybe large covered. So this it is the considerations and requirements, and we think it should be taken into account according to the enhancement of the DETNET state plane. So last slide, please. So the enhanced functions and the metadata and the control plane extensions are open to working group, and it may be lead to be aligned with requirements and the framework. So we call for co-authors to provide a more visible and achievable way to progress this work. And their comments and questions are appreciated. Thank you.
Hi, Quan. Thank you for your presentation, and thank you for mentioning that the update considering the controller plan requirement. So if you think there's any new requirement that has already not covered by the existing controller plan framework document, please make it in the main list. Maybe we can discuss further. This is the first comment, and the second comment maybe question for working group chairs also. I noticed that there are two documents about the requirements for large-scale DETNET. And I'm wondering, there is a milestone for, I noticed there is some echo here.
Quan, I'm going to mute you. We're getting a lot of feedback.
Yeah, thank you. I'm just wondering whether the requirement for large-scale network is equals the requirement for enhanced DETNET. I think that the basic concept is whether the enhanced DETNET equals large-scale DETNET. That is for, I think, maybe request further clarification. Yes.
Sure. I mean, I read this document as large-scale driven enhancements, so not a general comment. And it pretty crisply defines two of the requirements that were discussed in the prior draft. And we heard that the authors are working together to bring that text in. And so the plan is to bring that text in after adoption. So a lot of this document that was just presented is going to end up being in other documents. Happy to hear that some of it might end up in the controller plane document, in the framework document. But we still think that there's a piece of work here that is not covered elsewhere. So there's still useful pieces that will end up after breaking it apart.
Yes, but my question is that whether enhanced DETNET equals large-scale DETNET.
So I can't speak in general. I can just speak about this specific document. This specific document is about large scale and enhancements to support it.
Okay, thank you. Thank you.
Quan, if you have anything else, you can rejoin the queue. I just muted you because we're getting a lot of echo. All right, we have Daniel in the queue.
Daniel Huang from ZTE. Actually, from my primary understanding, Chen's presentation drops this for the a enhanced DETNet architecture. I'm also aware of the requirements documents and Xuesong's controller plane documents. But from my point of view, there's the massive flow issues and the queuing mechanism, which is absent in our current DETNet architecture. So I believe there's this space for enhancement and the new features to put into another or an updated architecture for enhanced DETNet. Thank you.
Thank you for the comment. We look forward to further discussion on the list. Peng, you went in and out, but is it okay to take it on the list because we're out of time for this one? Please.
I remember that some of these, the draft has been merged into the requirement of large scale, and the rest hasn't gone to consider and need to be discussed more, I think. Yeah.
Yeah, so
We have
there might
discussed-
still be, there's still text that'll be in its own document. That's okay. I think we can talk more after if that's not clear. Jinu? Great. Hello. It's good to see all these faces in the room.
Yeah, it's my first time. So asynchronous deterministic networking framework for large-scale networks. It's version 1. Yeah, the red letters indicate the revision or edit text. So the scope remains the same. It specifies the framework for both latency and jitter bounds guarantee in large-scale networks. So the framework remains almost the same. So the framework decouples the latency guarantee problem from the jitter guarantee problem. But now the latency guarantee solutions include a metadata-based forwarding, as well as the regulators. Okay, next, please. Next slide, yeah. So we can classify the solutions into 3 categories. First, flow regulation-based. Second, packet metadata-based. And third, slotted operation-based. Now the proposed solution in this document include 1 and 2. So the 2 packet metadata-based forwarding is now included. So metadata-based forwarding has its own disadvantages, but this can be compensated by the performance advantage of the solutions that I am going to present. Next slide. Yeah, so the existing framework already includes the regulator-based solutions, the IETF. Next slide. Yeah, next slide. Yeah, FAIR. And the next slide, please. Yeah, port-based flow aggregate regulations. These are introduced in the last version. Next slide, please. So in version 1, this solution is newly introduced. There is latency guarantee framework metadata. So here I'm going to present a brief background about fair queuing. One such example is the virtual clock by Zhang. It's based on the finish time. The finish time is service finish time of packet in an ideal fluid model. It is used as a service order in realistic packet-based model. So the smaller FA, finish time, gets earlier service. The finish time is determined by the fair distance from the previous packets in the same flow or from the packet's arrival time. So this equation shows the exact relationship between the F P-1, which is the previous packet's finish time, and AP, which is the arrival time of the packet P. And between these two, the maximum value is added to the L divided by R, which represent the fair distance from these two packets. So the fair queuing is known as a very good performance with fairness, but it requires to know that FP-1 has to be known. So the FP-1, which is the previous package finish time, is representing the flow state. So that is the major drawback. But however, we propose to use the fair queuing scheme in a core nodes without flow state. In order to build such a solution, those necessary conditions are within a flow, we have to keep the fair distance between the consecutive packets, and we have to preserve the actual service completion order within the flow, and we have to reflect the time lapse as hopes progress. That's the necessary conditions within a flow, and across the flow, those finish times of different flows has to be aligned. And for example, in virtual clock, they are aligned to the current time AP. So these are the necessary conditions. Okay, next slide, please. So here we propose a solution, which is a global finish time-based forwarding framework. It has four steps. First, it has to obtain the finish time at the entrance node, just like in the virtual clock. So in the entrance node, we have to keep the flow state. That's the mandatory. But in a core node, in a core node, we can increment the finish time of previous node by delay factor. It is represented as DHP, which is increment factor of finish time of P at node H. And third, the DHP has to be non-decreasing function within a node busy period. The definition of the node busy period is written in the draft, so you can refer to it. And it has to be larger than or equal to the actual delay. So that equation has to be met. By these three solutions or steps, the conditions in the previous slide that are met. And we include another step in 4. Preserve the service order of packets from the same input port, regardless of the flow. So that's slightly unrelated to the 3 other solution steps. But anyhow, by solution 4, we can use per input port FIFO-Q. So the figure on the right, bottom right, is the implementation practice. It has FIFO-Q per input port, and M represents the finish time marker, and S is the selector of packets among those input port Q, which has the minimum finish time. And we can update the DHP at that S as well. So here the metadata to carry in a packet is F and D. And these 2 data is dynamic and need to be updated. Next slide, please. So by this solution, a simple FIFO implementation is possible. And the metadata are not very difficult to manage. DH can, for example, DH can be UH, the maximum latency node for any flow. With such an example, a packet with maximum latency does not delay more than it would in a stateful virtual clock. And this solution is work conserving, which is different from the well-known solution from Ion Stoica, which is non-work conserving scheme. And it approximates the packetized rate proportional servers whose end-to-end delay bound is given by that equation. So here the B is the maximum burst of the flow, and H is the number of hops, and so on. But you can notice that the equation does not depend on the maximum burst from other flows. So in that sense, you can say the flow protection is achieved. So it's a great feat, great achievement. So here the jitter guarantee
You're
framework.
just about out of time, and
Oh.
there's a question. Do you want to take the question before you run out of time?
Yeah, okay, so question first.
Just remember, join the queue.
Yes. Hi, Greg Mirsky, Ericsson. I'm a little confused. So you say that this mechanism provides guarantee of latency and jitter.
Just latency.
Okay, latency. Okay. But I don't see that it really provides 100% guarantee. So basically that you guarantee that your packet will arrive within the given credit, unless this credit over-provisioned, very too big from what application wants.
Yeah, actually, there is a condition for the latency guarantee, but that is very simple one. The total arrival rates from the flows does not exceed the link capacity. That's the only one condition that has to be met.
So does that require that each and every transit node performs shaping and policing to maintain their behavior of all flows?
No shaping is necessary here. No regulation is necessary.
Well, at least from empirical experience I have, statistical multiplexing will likely to really affect your expectation, and this mechanism might improve on-time delivery, but I'm skeptical that it will really guarantee it.
Actually, fair queuing scheme is very well known, which was devised like 20 years ago. And it is known as a best performance solution. But the only drawback of the fair queuing is that it has to keep its flow states. When the number of flows are hundreds or thousands or even billions, then keeping the flow state is very difficult.
So we have just a couple more seconds. Lynn and Ishan, we're not going to have time for you. I'm sorry, if you could take it to the list.
Yeah, two questions. One question, I don't see, do you need the reservation?
Oh yeah, reservation is necessary.
Okay.
Reservation is necessary.
Okay, so if you have a reservation, then you have to tell the latency you guaranteed, right? Tell the user.
Yeah, that's correct. If the reservation is properly done, then usually the latency is guaranteed. But how small it is, that's the big problem.
Yes. So what is the estimation of the latency you guarantee the customer? Do you need to tell them, or you have some? I don't see any estimation here.
Yeah, I just showed you the equation at the last discussion slide.
The problem is that for practice, right? Those value has to be quickly estimated. You cannot have some complex math in the engine to do that.
Yeah, I'm sorry to do this. I really am. I like this discussion. I actually love
we can
mechanisms,
discuss
but if we
offline.
could talk about it.
Yeah, it's too technical, yes.
Yeah, yeah. No, it's great to get this technical. We just don't have time. Thank you very much. Look forward to further discussions on this.
On the list, please.
Yes, on the list, please. Ooh. I'm getting the sense there's a lot of interest in queuing mechanisms, and maybe we should plan an interim where we can have some much larger time for deeper discussion. It's really good seeing the technical discussion. Thank you.
Okay, I'm hopefully not as mumbling when I don't have a mask on. All right. This is a new version of our ongoing work called DETNET tagged cyclic queuing and forwarding. Over the prior versions, we also have a new co-author in it. Next slide. So I wanted to kind of revisit the scalability issue for large DETNETs. And what I'm showing here is a larger network with, let's say, 100 edge routers where the DETNET flows originate, the ingress PEs 1 to 100 and 100 egress PEs, EP 100 to 1. And then in the middle, there is some outgoing interface on the P1 router where all these DETNET traffic flows go through. At minimum, we need one aggregated DETNet flow for every combination, ingress to egress, and that gives us 10,000 DETNet flows. And unless we have mechanisms like the TCQF that we're proposing here, that means we would have to have in RFC 2211 INSURF 10,000 flows with per flow shaping, and in IEEE ATS asynchronous traffic shaping interleaved regulators for 10,000 flows. And for both of these, every time any of these flows changes its aggregate parameters, we would need to signal those aggregate parameters to all the routers along the path. So this ultimately is the problem that we're trying to solve with TCQF, because what we would need is a limited number independent of the total number of PEs of cycles, 3 to 5. And there wouldn't be any change in the IP router configuration on the midpoints when flows are added, change their bandwidth or what have you. Next slide. Okay, so sorry, this is a PowerPoint overload, but this is meant to be read also offline for. The traffic steering is pretty much about we need reservations along the path, and if we want to make that scalable, how do we do that? Because the traffic steering based on a 5-tuple would also be 10,000 5-tuple flows that we would need to statically nail up. We had basically similar solutions in MPLS with RSVPTE. We can build something like 10,000 RSVPTE flows, but we all know, hopefully, you know, a lot of us who had been in that space know what the limitations are in terms of performance, speed, and other issues. If we would do the same thing with static 5-tuple provision static routes, the issues would rather be worse than, RSVPT, which over the time had been very well enhanced. So the solution is really source routing. So there's SRMPLS, there's SRv6, there is BRTE for multicast. These are all stateless source routing based traffic steering that can nail down a path so that reservations can be had. And effectively, the TCQF would also very well enable this. Next slide.
Just a quick question here on clarification. Do you care what the setup mechanism is for your queuing mechanism?
No, no.
Okay, because you just made a very strong statement there, which was different from the document. So it was just surprising. Thank you.
Oh, now I'm confused. So maybe we can take it offline for a matter of time. So the benefits, so we're starting with CQF as from TSN. So we've got the scalable low-cost hardware implementable at 100 gigabits. We tested that in a network in China. We've got the bounded latency with extremely simple latency calculus, and we have the very tightly bounded jitter, which eliminates the need for clock synchronization to a lot of client devices. So then the CQF problems we solve is, instead of relying on very accurate clock synchronization, we're having the traffic tag in the packets. And that requires us to use multiple buffers and have a field in the header where we indicate the cycle identifier, and that is the traffic class field as we had for MPLS. And now, since the last version, also just the DSCP field for IP and IPv6. Next slide. Right, and so what we had in before was a draft that explicitly said we're for MPLS only, because our misunderstanding, well, my misunderstanding, I don't want to make my co-authors guilty on that, was that we wanted to have a standard DSCP code point, and that's right of heart. So David Black reminded us that we're really, controlled networks, so we can perfectly well use the private DSCP space, which is XXXX11 experimental LU code point. So we have 16 tags there, much more than in MPLS. So we can perfectly well support MPLS and IPv6 without any extension headers. So that's pretty much, what the text change is, and the draft name change. Next slide. Okay, so the long story. The long story is that what we would be suggesting is that this is as good as I think we can get a large-scale DETNet queuing solution with bounded latency, with bounded jitter, deployed for high-speed networks, and has been proven it can build on all the experiences with CQF. We have a lot of really interesting and cool work for what I would call longer term, which in my opinion all depends on having additional header for additional new tagging. And I really think that there is a lot of convergence needed across the different drafts that we have out. And so I was trying to summarize this a little bit, right? I don't think we want to, in the end, have 3 or 4, headers for DETNET that all need to be used in a sequence or so, but that everything we need in DETNET would be in a single extension header. And ideally, given how MPLS is also working on new extension header architecture, that could even be shared across IPv6 and MPLS. And so maybe that's one of those next overall things we may want to talk about, how we can start converging the different ideas. And I'm specifically pointing this out because I don't feel, I want to promote any, specific extension header work unless we do all that. And so if we want to get something quickly to deployable solution, this solution here using just the existing DSCP and TC would hopefully be ideal for first generation. Next slide. I think I'm done, right?
You have a few more, but it's up to you how you want to manage the queue.
Yeah. So this is pretty much the marketing of that, right? So all the things I think we obviously would want to ask at an appropriate time for working group adoption, would love to hear feedback on how to go on with this work, as well as the thoughts about the long-term work. Thanks.
Thank you. Let's have the queue.
Okay, thank you. Greg Muski, Ericsson. I have a couple of questions. So first, I think that's the second slide where you list multicast path controlling technologies. So my question is, in your opinion, is this exhaustive list?
So right now, I don't know a stateless multicast path control, right? Obviously, I have RSVPT point to multipoint, but then again, I have a total number of flows that I need to think of.
Yeah.
Maybe there's some other tricks to get down to the same scalability, but I just know with BRTE, in the same way as segment routing, I can have the hop-by-hop path without having per flow state on every midpoint.
Right. So I would point that in the same way as a SRMPLS or a Service6 can be strict, explicit path routing, so in beer. So.
Oh yeah, that's what I meant.
No. I'm sorry to interrupt you, but if you believe that this list of 3 technologies is exhaustive, then you miss to mention beer, not BRTE.
So in
it's
beer,
different. You know that.
Right. But in beer, I don't have hop-by-hop nailing of the path.
No, why? You can list all these nodes in the same way as you list them in the Service6.
But if I have IGP rerouting, I will have a change in the path for which I don't have the reservation.
Then it's the same way applicable to a Service6 in a SRMPLS.
So we're out of time.
There is no difference.
Can we take it to the list? I think
yes. And another thing is that
Greg, is it okay to take yours to the list so Shusong has a chance to say something?
Okay, I just want to invite everyone to join Pal's session where the discussion of MPLS open design team will be discussed, because it's not what you think it is.
Thank you. Shusong?
Hi, Xuzong from Huawei. I'm happy to see that there is some solutions that request no further data plan extensions to support bounded latency. And I think the suggestion from David is valid and very useful to use private DSCP. And I also agree that we need some interism for this topic, because people are really interested in different kind of queuing mechanisms and requested data, metadata. So just maybe working group chairs could help to work it out together, make people get together and work it out. Thank you.
Yeah, I think that's become very clear in this session. Thank you. The next is Li Zhang. You're online, please go ahead.
Yeah, this is Li Zhang from Huawei. I will introduce the DETNET enhanced data plan. Next slide, please. In this version, firstly, we add some examples for different kinds of bounded latency information in the appendix for ease of understanding. Secondly, we communicate with the author of draft eJOE DETNET IPv6 options for CQF variant and consensus to use BLI options in the draft. Thirdly, we add the China Mobile as a co-author. Next slide, please. To meet the goal of minimum and maximum end-to-end latency in data plan, DETNET uses metadata flow ID to identify the DETNET flow, but didn't define the metadata to guarantee the end-to-end latency. Now, there are other requirements of DETNET data plan in draft requirements for large-scale DETNET, including explicit inclusion of the metadata used for traffic treatment, compatibility to different underlying network technologies, etc. Next slide, please. To meet the requirements of bounded latency, there have been several mechanisms proposed in DETNET. The list on the left is the existing mechanisms, and the list right are the corresponding drafts. Next slide, please. So in this draft, we propose a new DETNET specific metadata called bounded latency information. It is carried in data plan used to facilitate DETNET transit node to guarantee the bounded latency. As shown in this figure, bounded latency information is transmitted across multiple DETNET transit nodes and used by DETNET forwarding sublayer. Next slide, please. So this page discusses the design principles. Firstly, we think the bounded latency information should be carried in data plan to facilitate DETNET flow to map the forwarding and scheduling resources, not focus on the local mechanism. Secondly, we think it's good to have a uniform format to accommodate various scheduling mechanisms. Secondly, we classified the mechanisms mentioned in the previous page into two categories, and one is a requirement, which summarizes the requirements for DETNET service and map to the resource. And another is resource, which indicates the resources. Next slide, please. In the BRI data field, we use the BRI type to indicate the type of bounded latency information, and the BRI format is used to indicate the format of bounded latency information. For the field of flag, currently we didn't have any definition for it. It is reserved for the future study. If there are any new mechanisms or algorithms accepted by DETNET and the bounded latency information is different with that in the table, we will add it. Next slide, please. For the IPv6 based DETNET data plan, we define a new IPv6 extension header option called the BRI option. This BRI option can be encapsulated in either IPv6 hop by hop or DOH extended header, depending on the processing behavior. And there may be more than one bounded latency information can be appear in one BRI option. Next slide, please. Similar to the IPv6 based DETNET data plan, for the MPLS-based data plan, we define a new MPLS extension header called BRI extension header. The processing behavior of MPLS is very similar to IPv6. Next slide, please. The BRI can be also encapsulated in MPLS over UDP and IP-based DETNET data plan. Next, please. For the ease of understanding, we provided some examples to give instruction on how bounded latency information is used in different algorithms, as shown in the figure below. Next slide, please. So next steps, we would like to have more discussion on BRI field, and collaboration is welcome. Thank you.
Okay, thank you very much. Yeah, there was a request at the last meeting from Dhruv to separate out requirements from solution so that they could use the requirements in other working group documents, in other working groups. Have you given any consideration to that?
Yeah, let me consider it after.
Okay, so again, the suggestion was have two documents, one solutions and the first document be requirements. And so we can have a requirements document that you can have multiple solutions against. Thank you. And Kwan?
Yes, thank you.
Present the work. I also agree to carry the information in the net enhanced data for the functions to ensure the dismiss latency. But it is an important intention. But we also submitted a draft to propose a general and common solution to carry the metadata for queuing mechanisms, but with just with the different terminologies. And another question, I noticed that your BRI type also indicates a queuing mechanism or algorithm, but how to distinguish two queuing mechanisms with belong to the same type? For example, the EDF and the DETNET algorithm, which is proposed in separate drafts, and how to use the time resource ID. Thank you.
Okay. Perhaps take the response to the list. And if we could get, thank you for the question. Xiaofu? Please go ahead.
Thank you. Thank you, Chair and all. Xiaofu from ZTE, I will introduce the scheme about the deadline-based forwarding. Next, please. So in this version, we have the following updates. The first is update abbreviations for ease of reading. The queue has three attributes: countdown time, and authorization time, and the rotation time interval. And we also updated the packet queuing rules. The packet allowable queuing time is larger than countdown time and less than the countdown time adding authorization time. And updated the queue allocation rules, and the traffic regulation and orchestrating are English, and the potential reshaping and transit and given the schedulability conditions. And we also provided the delay compensation and deployment considerations. Next, please. Oh, just wait the screen to be shown. Sorry. Okay. The motivations for this document is to fund the application queue mechanism for large-scale networks. We know the uses of existing mechanism that is suitable for the small scale network such as CBS and the ATS come with a high latency variance because the minimum latency is not affected by this mechanism. And CQF is quite challenging because it requires time synchronization. The widely used priority-based queue scheme will give better average latency, but with worst case latency. So this document proposes a variant of EDF scheduling to dynamically rotate the priority of each aggregated 5 queue and uniformly provide the bounded delay jitter. Next, please. So wait the screen to be shown. Okay. The deadline queue has 3 attributes. Countdown time indicates the countdown waiting for scheduling. The rotation time interval indicates the decreasing step of countdown time. And the authorization time indicates the continuous sending duration when the queue is scheduled. There are 2 sets of isolated queues, in-time queues and on-time queues. The queue has the highest priority if its countdown time equals to 0 in despite of in-time or on-time mode. If the countdown time is larger than 0, then the in-time queue has normal priority, i.e. that is work concern. But the on-time queue has the prohibition priority for non-working consumer mode. The following picture shows a single deadline queues with 4 deadline queue. And the size of queue is the port bandwidth multiple the authorization time minus the maximum interference size with no priority. Next, please. So these are no latency. Sorry. Okay. For the packet queue rules, first we will get the deadline information of the packet, include the planned residence time, the accumulated residence valuation, and the forwarding delay. Then we can put the packet in the specific deadline queue based on the queuing rules. The following picture shows 6 packets from different incoming port then put to the deadline queues. Okay, I will not show in detail. Next, please. Just wait. Okay, I will speed up. Then this slide shows the traffic regulation and electricity trading. First, we made the regulation and electricity trading English to put the package to the specific authorization time. Then we get the schedulability conditions, reshaping per flow, all per aggregated flows and transit. These work to be further studied to show that the worst case delay if increased by the receiving. Then this slide shows the schedulability condition. In fact, the condition is simple for the planned residence time and the associated the traffic arrival constraint functions. Next, please.
You really have to start wrapping up to be fair to the next 2 presenters.
Okay, there's a long latency. I just waited the screen to be shown.
Quick.
Okay,
Yeah,
I see the last.
very quick comment. Thank you, Shafu, to bring deadline-based queuing mechanisms, considering there are a lot of previous books about the deadline-based queuing. So I think it will be very helpful to provide some background information and to explain what brings new to the previous work in this document. Thank you.
Okay, thank you.
Yeah, definitely hope to hear more about this in an interim. We have Zhuyan Song. Do we have the presenter? Next presenter? Thank you.
Okay, thank you. The document is about MPLS substack encapsulation for DLA. It's Xueyan from ZTE. Okay, next page. In this revision, we updates include gap analysis, added terminology, updated resolution, updated MPLS substack for DLA, and updated flat field and ANA registry. Okay. For gap analysis, we use two drafts as basis. First is about the bounded latency WG draft, and second is about RFC 8655. So for the bounded latency draft, we use the basis. First, end-to-end delay bound equal to non-queuing delay bound plus queuing delay bound. And the end-to-end latency bound flow can be equal to the sum of the delay in H nodes. And the third point, DETNET PRUF function addresses traffic congestion, jitter reduction, and service protection problem. Okay, the second question, what is the gap? To compare with TSN, DETNET can support time-sensitive service because it has no queue processing function support in large scale. And how to resolve the gap from our perspective, there are several considerations. First, the right queue selection and mapping of network resources with specific queues, and necessary latency information encapsulated in packets, and the information processed hop by hop. And where we are, two data plane drafts have been submitted. One is for MPLS encapsulation, and the other is for IPv6. Okay, next page. In this document, except the existing terminology used, we also propose two new terminology, deterministic latency and deterministic latency action. The deterministic latency term is first used in this draft, the new DETNET large-scale requirements. And this is the definition from our perspective. It's a bound of network latency and delay variation between two DETNET endpoints. It may also include parameters such as bounded latency, bounded delay variation, etc. For the DLA term, it is used for MPLS substack. Okay, next page. The resolution. First, the right queue option selection. This is the first step. And second is for which type of queue option to select. And now in this document, we use TS, CBS, and CQF. But maybe it's not mature. It also may need for further study. So we will update this. And the second point is about the mapping of network resources with queues. This mapping policy may be per flow ID, source destination address, MPLS label, etc. And the necessary information encapsulating packets may include DLA indicator, specific queue option, and detailed latency information. Okay, the next page. Okay, this is a format encapsulation for DLA. First, we use the reference and MPLS WG. The first reference is about IETF MPLS M&A framework document, and one individual draft. This individual draft have received wide consensus in MPLS WG, so we use this to draft as reference. For the encapsulation, the first figure is for the NAI indicator encapsulation. And the second is for the ancillary data format. It uses TLV format. For the first figure, the NAI opcode is to indicate the DLA indicator. And the flag-based NAI, we have specified three Q, the TPC, okay. And for the NAL, the NAL field is used for the indication for the numbers of LSE, followed by the NAI indicator LSE. Okay, IHS field is used for the A2E or hop by hop option selection. Okay, so next page. Okay, the IANA registry and flags field. First, we want to express our thank you for IANA review and comments. Thank you, Amanda. These updates has been indicated in the new document way03. Okay, and for next steps. Next steps, we will update terminology and the resolution section, and we'll also update packet format encapsulation to align with the process of MPLS WG and comments and question. Thank you.
Perfect timing. Thank you. We'll move to the next and last slot. I'll point out that earlier in the presentations, there was a request to separate requirements from formats. And you might have an opportunity to collaborate on that requirements document, because it seems like there's some good alignment in what you're doing in that document. And with that, Jiyan Song, and I really apologize to anyone whose name I mispronounce.
Yeah. Okay, I'm Xueyan Song. Okay, this document is about YAM data model for DETNET mapping with network slice. Okay, the agenda for this draft, the first problem statement, applicability of DETNET to network slice, and the mapping process and requirements, YAM modeling approach, and next steps. Okay. For problem statement, first we use reference RFC 8655. The advantages for DETNET and its limitation for the use in large scale. Okay, no, not in large scale. Sorry for the table. Okay, the advantages for DETNET, it can provide low packet loss rates and bounded end-to-end delivery latency service to DETNET flows. And it can also provide dedicated network resources and can apply to any applications. But its premise for DETNET with network resources delivery, its premise is that the network resource should be reserved by the existing protocol. But the existing protocols such as RSVP can satisfy resource guarantee for necessary time, bandwidth, buffer, and other network resources reservation and optimization. So to resolve this question, we think network slicing can help to resolve this problem. Okay, next page. IETF network slice, actually it is specified at TIS-WG. And from the definition of IETF network slice, it enables connectivity between SDPs with slows and slays. The slows parameter may include guaranteed minimum bandwidth, guaranteed maximum latency, and so on. Slays parameters. IETF network slice provide NRP. The NRP is for network resource partition, which consists of a subset of buffer queuing scheduling resources in the underlay network. It can be applied to slice flow or slice flow aggregation. And through NRP, it can meet specific network resource requirements. Okay, so in this draft, we provide the applicability of DETNET to network slice. Okay, next page. From this figure, you can find there are three main parts: IETF network slice controller, network controller, and this is about the underlay network. The example is for a low latency deterministic service. And the service user is from the TSN endpoint, and its destination is DETNET endpoint. So to support the low latency deterministic service, the user should first request necessary resource. And through the applicability of network slice to of DETNET to network slice, the user would first request NRP, the NRP to IETF NSC, and IETF NSC, when received the request, will allocate or deploy NRP policy to the underlay network nodes, the PE and P, and after the underlay network deploy or complete resource reservation and rapid computation, will the deterministic service flow will be mapped to the underlying NRP resources and to the destination. Okay, for the mapping process, first is about the DETNET app flow instantiation, and the second is about the mapping policy of DETNET flow with NRP mapping policy. And the third is about the policy deployed to the underlay network nodes. And the fourth bullet is about the corresponding identification mapping. And and through the network resource occupation by hop, the network resource maybe can be realized and guaranteed. Okay, the requirements. The requirements we describe from the aspects. First, the mapping of DETNET with NRP, And a second is DETNET with an existing NRP. If there's no NRP, the NRP needs to create it. A new NRP will be generated, and the DETNET flow can share the same NRP, and the NRP should provide the buffer queuing schedule network resources for DETNET. Okay, so next page. The YANG modeling approach, first we augment DETNET YANG and import the DETNET NS mapping types. And for the service model, we augment DETNET service sublayer and to import the DETNET network slice mapping templates and to realize the mapping of DETNET flow ID or some other parameters with the NRP ID. Okay, next page. Okay, this is about the next steps. So thank you very much.
Thank you very much. Clearly, we have to coordinate this with the TEAS working group and make sure the terminology and the work is aligned and supportive. Thank you all for participating. We've had a pretty busy session, and clearly we have a lot of interest in queuing, and we'll find a time to have more conversation about that. Thank you all. Hope you have a good week.
Thank you. Bye.
A lot of queuing. Yeah.